Hello everyone, welcome back for another lesson. So we've been talking about mechanical engineering and we've been talking about systems and we've been talking about motion sometimes. We talked about guiding control, for example. So we will be focusing now on various systems that either transmit or transform motion. We'll begin with the transmission of motion or motion transmission, as you can see here. All right, so let's start with some vocabulary. So a system, it's a set of components in an object that share the same function. So they do the same, they work towards the same goal. So in a bicycle, for example, you've got the pedals, you've got the chain, you've got the sprocket, you've got the wheels, and they all work together to make the bike move forward. So that's a system. Motion transmission system, it's a system that relays the motion without changing the direction of the motion. We're transmitting, we're not transforming. So transmission, it's the same type of movement that goes from A to B to C. A driver, that's the root of the system's power. Sorry, I have a mistake here. There should be an apostrophe over here. My bad. So the driver component is a component that initiates the movement. Okay, so the pedals, for example, in the previous example of the bicycle, sorry. Okay, so this is the component that receives the force from the user. The driven is the component, there could be more than one, of the system that receives the motion from the driver. So the driver, in this case there's two, it would be the pedals, and the pedals would then transmit their movement to all the other components, the chain, the sprockets, and so on and so forth. Now, it could be that a system is reversible. In other words, the driver can become the driven, and the driven component can become the driver. So any component can be the driver, any component can be the driven, and it will not break the system. It will allow the system to still function. Maybe in reverse, but it would still function. Now let's look at more specific examples. Oh, no, before we do so, more vocabulary. Okay, so we've got three types of motions: translation, also called linear; rotation, also called circular; and helical or spiral. In other words, there's rotation and translation at the same time going on, done by a specific object. So we're going to be looking at 5 different types of systems, which are listed here, and we'll talk about them one at a time. All right, the first one. Gear trains. Okay, so you've got various gears, so they're wheels with teeth. The teeth have to be the same size for them to fit together, like here. Not the wheels. The wheels can be of different sizes, but the teeth themselves, if you want them to fit together and you want the system to work properly, they have to be of the same size. So they can fit. So they can fit inside one another. So they'll turn automatically in opposite directions if they are touching each other. So you've got gear A, which is turning in this direction. Well, it's going to be opposite to gear B, which is going counterclockwise. So gear A is going clockwise, gear B is going counterclockwise. If you look at gear C and D, C is going counterclockwise, D is going clockwise. Okay, so type of motion, obviously rotation. Is it reversible? Yes. Let's say this one is initiating the movement. Well, this one would be the driver and all others would be the driven. But it could be that this one will become the driver and all three, the A, B, and C would become the driven component. So this is reversible. So that's for gear trains. Next we have friction gears. So it works in a similar way, except that these don't have teeth. So these are making each other turn, but based on friction. So you don't want to use a lubricant there. You want actual friction, because otherwise they'll just slip and they won't turn. So friction wheels are like a gear system without the teeth. They turn in opposite directions. I don't know if I mentioned that. So this one, for example, would turn clockwise, making this one turn counterclockwise. It's the same idea as with the previous example. It's reversible because the driver and the driven are interchangeable. And the type of motion is rotation. Then we have chain and sprocket. Very similar to gears, except that they're further apart. So because they're not touching, we need a component in between to make them work together. And in this case, it's a chain. So we won't call these gears, we'll call them sprockets instead, just to make the distinction. Now, in a system like this, all the sprockets that are on the same side of the chain, so all the ones here that are on the inside, they all turn in the same direction, clockwise. And if a sprocket is on the outside, for example, in this example, it will turn counterclockwise. Okay, so it'll turn in the opposite direction. So all the sprockets that are on the same side of the chain will turn in the same direction. Doesn't mean it's going to be automatically clockwise. It's just in this example that's the case. And all the sprockets that are on the outside, if I had more on the outside, they will all turn in the same direction. In my example, it's counterclockwise. So they're further away from each other. They need a chain to link them. So in a bicycle, that would be an example of a chain and sprocket system. So you have the pedals that are attached to sprockets. You have a chain that is linking the sprockets that are attached to the wheel, right? And so the type of movement is rotation, obviously. And again, it is reversible. So the driver and the driven are interchangeable. Next, we have the belt and pulley, which is very similar to the chain and sprocket system, except that the wheels don't have teeth. So these we're going to call pulleys, and we have a belt that is linking all the pulleys. So these pulleys being all on the same side of the belt, they are all turning in the same direction. In this example, they're all turning, let's say, clockwise. Okay, so it's just like for the other system, whatever is on the same side of the belt will turn in the same direction. If I had pulleys on the outside, they would all be turning counterclockwise. Okay, so this obviously is an example where we have rotation as a type of motion. And again, this system is reversible. The driver can become the driven, and the driven component can become the driver. Next, we have the worm and worm gear. So it transmits a rotational motion to non-parallel parts. So rotational motion, right? And these parts are not parallel. They're on different axes. So they both have teeth, and they obviously fit inside one another, otherwise it would block. And the teeth of the worm gear fits inside the worm. So this is the straight part. That's the worm, like a worm that you would find in the ground. That's how I remember it. So this is the worm, and this is the worm gear. And we know it's a gear, so it's easy to remember. So here we have a rotation in a certain direction, and we have rotation in a different direction for the gear, but they're not along the same axis. So the type of motion, rotation. Is it reversible? No. If you try to switch the worm and the worm gear in terms of driver and driven, the system will block or will not do its work properly. So the worm is also called, by the way, the endless screw, because this is like a screw, but it can turn forever and ever and ever. It won't slip off the system. Okay, and that is the driver. This is always, always the driver, the worm is. And the gear is always the driven component. So here we have a summary of the different motion transmission systems we talked about. So do the wheels have teeth or not? Are they touching or not touching? So in the case of the chain and sprocket and belt and pulley, for example, they're not touching. They're linked by a chain or a belt. The type of motion is rotation in all cases. Do they turn in the same or opposite direction? They're all in opposite direction, except for the two that have either a chain or a belt. But there's an exception to that, right? So they're going to turn on the same side as long as the either the sprockets or the pulleys are on the same side of the chain or belt. Okay, so if they're all on the inside, they all turn in the same direction. If they're all on the outside, they all turn in the same direction. But if you compare something that's on the outside and inside of the chain or the belt, those will not turn in the same direction. Okay, so there is a little bit of an exception there. And are they reversible? They're all reversible except for the worm and worm gear, the last one that we saw. Okay, so that's it for the motion transmission systems. So unless you have questions, I will see you for your next lesson. And until then, take care.